The purpose of this section is to familiarize you with the concept of fluid flow. There are a couple different types of fluid flow. First, streamline flow, also known as laminar flow, is the smooth flow of a fluid. The particles follow smooth paths called streamlines. As we can see in the picture, the particles follow a rather straight path without running into the sides of the tube. The other type of flow is turbulent flow. It is also known as non-laminar flow, and it is the erratic, unpredictable flow of a fluid resulting from excessive speed or a sudden disturbance. As we can see in the picture, turbulent flow goes off in any direction, seemingly without rhyme or reason. The particles move all over the place. Let's take a look at a couple of different ways that we can get turbulent flow. First of all, if we have an object obstructing the path of the particles, we may get turbulent flow downstream, as seen in the first image. Some of the fluid may continue on its streamlined path, but other particles will be blocked. If the flow is moving too fast for the tube, you might get turbulent flow. In this case, the particles move every which way as they progress down the tube. They will run into the sides of the tube, causing even more turbulent flow. Lastly, if we have a bend in a pipe or a fitting that the fluid is forced through, this also creates turbulent flow downstream from the bend or fitting. Again, the fluid is being forced through a much smaller opening, so it may run into the sides of the tube. Now that we know how fluid flows, we can discuss the flow rate. The flow rate of a fluid is the volume of fluid flowing past a given point per unit of time. In order to calculate the flow rate, we can take the speed in feet per second and multiply by the cross-sectional area in square feet. This will give us units of CFS, or cubic feet per second, for the flow rate. We can think of the unit of 1 CFS as if we have a fluid that has a cross-sectional area of 1 square foot and it travels 1 foot in 1 second. This would be 1 CFS. One other thing that is important from this slide, we will need the conversion that 1 CFS is equal to 449 gallons per minute. In the next video, we will look at an example of how to calculate the flow rate.